Welcome everybody to our Polarion webinar about hazard management and risk assessment according to ISO 26262. My name is Carola Hartlieb. I will be your host today, and I'm speaking to you from the south of Germany, from a small town located near the Lake of Constance. So it's in the evening my time, but I guess for the most of you it is in the morning or around lunchtime. Before we get started, some details about our WebEx setup today. You have joined using the audio broadcast, and you have the possibility to ask questions using the WebEx QA panel or the chat panel. And I would like to encourage you to ask questions using the WebEx chat panel or the QA panel. If you ask questions, please address the question to all panelists, so my colleagues can see your questions also and can help or assist me in answering your question. What can you do if you get lost in our WebEx? If you get disrupted in audio or video during our webinar, you can visit our homepage at polarion.com, and we will record this webinar so you can replay the webinar later on, and you can look and download a free trial of Polarion from our webpage. Also, if you have any issues concerning audio or video, if the voice is not loud enough or my screen resolution is not good for you, please give me a hint in the chat or in the QA panel. So what will I show you today? First, we have 2-3 slides about Polarion itself. What is Polarion? Then we will look briefly into the concepts of the ISO 26262. And then we will look into more details how Polarion supports ISO 26262. We have time for questions. Also, you can ask your question during the webinar using the chat or the QA panel. So what is Polarion? Polarion is an ALM, an application lifecycle management solution, and millions of people are using Polarion today. Polarion offers a couple of products around ALM, so we have products with focus on Polarion requirements or Polarion QA, which is a collaborative test management, but all the products from Polarion are settled around a common framework. So you have only the decision by your license key which product will fit best for your needs. Polarion is a very open platform, so it adapts to all processes or methods. You can customize Polarion up to your needs, and as shown here, all the products of Polarion own one common kernel, and everything is tightly integrated. So you have support for requirements management, test management, change management, task management, build management. You get audit on metrics, and you get the possibility to check whether you are compliant to your process or not. You will always have access between the different areas. So if you are in the requirements management, you will get access or traceability down to your test management, your task management, or your build management. A quick look behind the architecture of Polarion. Polarion is a pure web-based application. So from the user or the end user point of view, you will use your browser, which is installed on your laptop, on your PC, and connect via HTTP or HTTPS with the Polarion server, which provides everything you need for your LLM, like the requirements management or task management. At the back end of Polarion, the repositories, which are used to manage all the artifacts of your project. This is a version management system, so you will get for free a so-called audit trail. You will know each time who has created an artifact, who has changed the artifact, what was the reason and what was changed from the user. So let's look into the ISO 26262, the main or the basic concepts. We will focus a bit on the hazard analysis and risk assessment concepts here. So let's start with an example. What is functional safety? The ISO 26262 is a standard focusing on the functional safety for road vehicles. So what does functional safety mean? What does it mean in the context of automotive? An application, it's an application that can cause harm. What's an application in the automotive area? It can be an airbag, it could be a braking system, it could be a window lift. And this application can cause harm. So what will happen if an airbag explodes when an infant is sitting in a front or in the front seat? Well, the infant will get injured, and this isn't good at all. So we need, or you need, to assess the risk. You will find a mitigation strategy or a safety function. So you may add an additional sensor which will detect whether an infant is sitting in your front seat, and this sensor will deliver a signal to your software or hardware controlling an additional actor which is able to disable our airbag if an infant is sitting in the front seat. So the functional safety in this case is that the infant in the front seat is not exposed to an unacceptable risk. The risk that an infant is injured if it's sitting in the front seat isn't removed completely, but you have done everything to mitigate the risk, and the infant isn't anymore exposed to an unacceptable risk. So the ISO 26262, where does it come from? It's the functional safety for road vehicles, and it's an adaptation of a very common standard, the IEC 61508. You see, there are a lot of domain-specific standards for the different domains, which are an adaptation of IEC 61508. So we are looking here into the ISO 26262 with a special focus on the functional safety for road vehicles. What are the main concepts or main components of this standard? ISO 26262 provides an automotive safety life cycle which covers all phases from your initial definition till disassembling of the product. What does this mean? The life cycle is mainly based on a V model, and the ISO 26262 will add additional steps or phases to your already existing V model concerning the functional safety. You're allowed to tailor the necessary activities during these life cycle phases. So it depends whether you will do a complete new development or a modification from an already existing product. The ISO provides an automotive-specific risk-based approach to determine the risk classes. It's called the ASIL, the so-called Automotive Safety Integrity Level. And this risk approach is based on the item. But what's an item? The item is the system or the product you develop. It could be, like we have in our example at the beginning, it could be an airbag system, or it could be another electronic controller unit like a braking system or a window lift. Or if we think more on the whole vehicle, it could be the whole car itself. These ASIL levels are used inside the standard to specify the necessary safety requirements which are needed for achieving an acceptable residual risk. Also based around the ASILs, the standard provides requirements for the validation and confirmation measures. ASIL, the Automotive Safety Integrity Level, is a key component inside the ISO. The ISO will be determined at the beginning of the development process. So it means not at the end, but it will be in the starting phase of your development process. What's analyzed? It's the function of your system with respect of possible risks or harms. Defining the ASIS, you will ask, if failure arises, what will happen to the driver and the associated road users? So it's a very high-level view from the point of the driver. ISO 26262 is split into 10 parts. The main parts are listed here. Each part focuses on a specific area of your development process. So part 2 is more or less the management of the functional safety, how you integrate the different activities, assessment or audits into your project management plan. Part 3, the concept phase. This phase mainly covers our hazard analysis, the risk assessment, and the definition of the ASIL. Then we have, looking here, the V model for the part 4, which is with focus on the system levels. We have part 5 focusing on hardware level, and part 6 focusing on the product development at the software level. Also, you see part 7 with focus on production and operation, and also from the point of a software tool supplier, very interesting part here is part 8 about supporting processes. This part defines not only how you have to define requirements according to the ISO or defining your configuration management process, it defines also that each software tool which is used during the development process has to be qualified, that this tool is able to support your process development or product development. So let's look a bit more in detail into part 3, our concept phase. Listed here are the steps which are defined inside the standard for our concept phase. So the first step is to define your item. Define what are the functions of the product I will develop, what are the interfaces to other systems. Next step is the initiation of the safety life cycle. Here you will decide whether development or the product is a complete new product or whether it's a modification of an already existing product. Next step is the hazard analysis and the risk assessment. And the last step defined in the concept phase is the definition of the functional safety concept. Here you will derive the functional safety requirements from your so-called safety goals and allocate them to a primary system architecture. Today we will look mainly into this step, hazard analysis and risk assessment. So looking into more detail into our standard, this step is already split into 4 more detailed steps. The first is the identification of possible hazards of our system. Then we will classify our hazard, and after the classification, we will do our hazard determination, and at least we will define the safety goals derived from our hazards. So how can you classify your hazards? The standard defines 3 parameters for specifying a hazard. So one is the probability of the exposure, the next parameter is the controllability, and the third parameter is the severity of the failure. Based on this, the ASIL will be determined. So our standard knows about 4 ASIL levels, ASIL A, B, C, or D, and you see ASIL D is the most severe ASIL level. So going back to our simple example, how will you determine the ASIL for our airbag system? So first we are looking at the probability of the exposure. This parameter is scored from E0 to E4, and the question is here, how often will an airbag explode while an infant is sitting in the front seat? Well, I guess not so often. We will be by our scoring around E1. The next parameter is our controllability. Scoring is between CO or C3, and it's asking, is the hazard controllable? Is the infant or the driver, or will the infant or the driver able to control the explosion of the airbag? I guess in the most cases no, so we will have here C3. Our third parameter is severity of the failure. What will happen if the airbag explodes? So here we have scoring between S0 and S3. S3 means life-threatening injuries. Yes, that can happen if an infant is sitting in the front seat and an airbag explodes. So we will have here E1, C3, and S3. And the standard provides a table where you go in with these 3 parameters, and you will find which ASIL level belongs to your hazard. So we have said, okay, we go in with severity S3, we will have an exposure of E1, and we will have a controllability rate to C3. So what we will end up is with an ASIL A. Looking at this table, you will see a lot of QM. What does QM mean? QM stands for quality management. This means the hazard is rated not to be so serious, and normal or the regular quality management methods are enough. You do not need to add additional activities to your process according to the functional safety. You only have to follow the ISO 26262 if you have an hazard rated with ASIL A, B, C, or D. So let's look whether we have questions so far. Okay, well, we have one question. It's a sample for a headlamp bulb, and the question is whether you need to develop this bulb according to the new ISO 2626 standard. From my point of view, yes. The answer is yes. You have to check whether this headlamp bulb can cause some safety-relevant issues. If, like I have shown before, if the result of your hazard analysis is that the ASIL, which belongs to your headlamp bulb, is QM, you don't have to follow the ISO anymore. But if the result is you have an ASIL to the headlamp bulb around A, B, C, or D, you have to follow the standard as well. So let's look what provides Polarion for you if you need to develop according ISO 26262. Well, Polarion itself is as I mentioned before, is an ALM solution, so it comes with a bundle of features which will help you to comply to ISO 26262 by default. You will get a traceability. This traceability is requested very heavily inside the standard. You have to ensure that the hazard is linked with the derived safety goal, with the derived functional safety requirements. You have to ensure or show that you have used all methods which the standard requests if you have an ASIL A, B, C, or D function in your product. Additionally, the standard requests that each software tool which is used during your process development needs to be qualified. Polarion is or has done a tool qualification with TÜV Nord and is qualified as trusted tools according to ISO 26262 up to ASIL D. Polarion is also qualified according IEC 61508 up to SEAL 3. Next component, Polarion provides you with so-called project templates, which will help you going through or help you supporting ISO 26262. There will be two project templates, one called Polarion ISO 26262 template. This provides support for the hazard analysis, and this is the template we will later see live in the live demonstration. There will be also a project template available which will provide you with all the use cases and test cases used during the qualification of Polarion with TÜV Nord. And the fourth component from the Polarion ISO 26262 support is we have done integration with other tools around or other tools focusing supporting ISO 26262 standard. So what we will look into detail is the so-called Polarion ISO 26262 template. What's the motivation behind these templates? If you look around, a huge problem in your projects is that there are project silos. We have the requirements management area, the development and release management, and the quality assurance. These silos are integrated well if you're using an ALM tool. If you look into the functional safety area, well, this area is mainly, or it's not integrated. There are at least no tools used, or if tools used, one of a very common tool is Excel to collect the hazards to do the ASIL determination. But there is a missing link to integrate functional safety with all your other project domains or disciplines. And this is the motivation behind the Polarion ISO template. It's the idea to integrate the functional safety concepts like the hazard analysis with the whole project development, to integrate the hazard analysis with your requirements management, with your design specification, with your task, with your test cases, so you have it all integrated and not segregated. So what will the ISO 26262 Polarion project template help to answer. It will make the functional safety, your hazard analysis, traceable and auditable. It will answer questions like, who made changes to my hazard analysis? When were the changes made? What was done to mitigate hazards? What action were taken to mitigate the risks? Does my ASIL inheritance, which is requested heavily by the ISO, complies with the standard or not? It will help answer questions concerning coverage. Do we have defined at least one functional safety requirement for a safety goal? So the template itself will add additional elements to your Polarion projects and is centered around part 3, the concept phase. If you look into the standard, there is a need for additional work item types. We will need a work item type to create and manage the hazards in our project. We have the need to create and manage safety goals and functional safety requirements in our project. The project template provides you with this additional work item types, also with additional fields for collecting all the information like the severity of a hazard, like the exposure of the hazard, like the ASIL level for a hazard or a safety goal. It comes with predefined link rows, so it is checked that a hazard is only linked with a safety goal, and each safety goal is linked with a derived functional safety requirement. It provides you with some specific workflow for hazards, safety goals, and functional safety requirements. Additionally, the standard requests work products like an item definition, a hazard analysis and risk assessment document, and a document for functional safety, for the functional safety concept. So the template or the project template comes with predefined documents helping to create these work products. Also, there are a couple of reports which will help you to check the traceability and the coverage and to prove the compliance to ISO 26262. Okay, let's check the question, whether there are questions before we start with the live demonstration. Okay, I guess no further questions so far. So let's start looking into the tool itself. Let's start with the live demonstration. The first scenario is we will examine a bit the ISO 26262 Polarion project template. We'll look at the additional work item types, at the documents, and the possible reports. Okay, here we are inside Polarion. I'm using a Firefox browser and I'm connected to my local servers, and I have prepared here a sample project which is created using the Polarion ISO 2626 project template. We have here our integrated wiki, which allows us to present all the information around our project, and we have here a special area which is the starting point for the ISO 26262 support. And let's just click in and we will start looking into this special area which was added by the ISO Polarion template. So we have here again the different parts of our standard. We see, okay, we have an overview about the hazards which are currently defined in our system, which are the status of our hazards. We have links to the relevant work products like the item definition. And we can or have here a so-called how-to, and let's start looking into this how-to a bit. This how-to describes in detail the part 3 of our ISO norm, and you see here the different steps like a hazard identification, a hazard classification, and here on the left hand you have a more detailed information, what's the standard requesting and how you can manage this with Polarion. The first step is the hazard identification. So you have to list the driving and the operational situation in which the hazard can happen, and you can create and manage hazards by using a special Polarion document, or you can create a plain new work item of type hazard. Let's go down here. You have the explanation how you can do the hazard classification, how you can define the severity, including a short description and examples for the different levels, also for exposure, controllability. You will or you'll find here the ASIL table, which helps you to determine the ASIL level. And the next step here, the safety goal determination. So very detailed how you have to use the standard and how you can do it with Polarion. So let's go back to our starting point. What else provides the Polarion ISO 26262 template? We see here a couple of reports. It adds work item types, and let's just look what's behind this hazard work item type. We will see currently we do have only one hazard defined, and on the right hand here you see the details of the defined hazard. And if you look here, you will find additional fields which are requested by the standard, like the ASIL classification. We will see here, okay, inside our description we have fields which relate to the operational situation, the operational modes, and consequence of the hazard fields, which helps you to define your hazard according to the standard. Here we will find the different parameters like severity, exposure, and controllability, which are requested for the determination of the ASIL level. And we will see here the link roles. So if we create or select this to create a linked element, the template ensures that you can only link a safety goal to your hazard. This is requested by the norm. If we go a step down and look into our safety goals and see here, okay, I'm allowed to link a functional safety requirement to my safety goal. This is also checked by Polarion, that you only link functional safety requirement to your safety goals. So what else is interesting? We have here the workflow, a specific workflow. So we are currently in the status analyzed, and the next status would be start progress. But I guess it's easier to look this up in our hazard analysis home. Here we have the reference to the workflow. We see our work item type hazard, an overview of its workflow, whenever you create a new hazard, it's in status draft. Then you will start your analysis. You will do the classification of the hazard, and after this, you will set your hazard to the status analyzed, and then the development will start. It's in progress, and after the whole development is finished, the hazard is completely and mitigated. Okay, what else? The template provides you with a couple of reports which helps you to ensure that you comply with the standard. One interesting one is here the report about the safety goal ASIL inheritance. So let's start it. This report focuses on the inheritance. So the standard or the rule inside the standard is for each hazard, one or more safety goal needs to be defined, and the safety goal inherits the ASIL level from the related hazard. So this report marks long inheritance red. So why is this marked red? Because the ASIL classification of our safety goal is QM and not ASIL B, which was or is the ASIL rating of our hazard. So this is your starting point. You have to check the safety goal and to correct the ASIL classification here. Next safety goal, yeah, there is everything okay. So the ASIL inheritance is the same. It's okay. What else? You can check the safety goal coverage. The standard requests that for each safety goal which is defined in your product, you need to specify at least one functional safety requirement. So currently we have fulfilled this rule only 50%. We have one safety goal which is not related to any functional safety requirements. So far for the first introduction to the ISO 2626 project template. Just let's check whether we have a question. Fine so far, I guess. So next demonstration scenario is let's look into the process of our hazard analysis using the Polarion ISO 2626 project template and using our sample project. So where will we start? Let's go back to our homepage of our project, and the sample we will use during this live demonstration is a sample about an electronic parking brake project. And if we like to get more information around our project, we can look it up using our item definition. The item definition is the first step in our concept phase. It's a specification of our item, of our product, a product we will develop. In this sample, it's an electronic brake system, and we will use some of the predefined Polarion documents. So we have here our header, which is shown the current release, what has changed for this release, who was the author and who was the reviewer. We have the different chapters, a short introduction about the purpose of this document. We can list references to other documents, and here is our item description, our overall item description. What features will be implemented by our electronic parking brake? Well, our parking brake will be applied and disengaged by a simple touch button, not with an additional handbrake. The function is to hold the car securely on any incline. We will have functions or a function so-called hill start assistance, which automatically release the brake according to the engine force. Our parking brake will be automatic applied whenever the ignition is turned off. And there is another function about brake pad rear indication. Here we'll see all the components of the electronic parking system. We define our operational modes. Very easy in this case. We have driving or stationary mode. We define the operational situations like parking on a slope or driving on an urban road. We define the interfaces and the boundaries of our product. So everything inside here is in our product, and we will get information from other ECUs or parts of the vehicle. We can have here links to functional requirements like business requirements. These are in this case more or less like the functions we have defined for our electronic parking brake. So this was the first step or work product which is requested in our concept phase, the item definition. This can be done using the Polarion documents. The next step, if you look into our how-to, is to define the possible hazards for our system, the possible hazards for our electronic parking brake. So if we follow the guidelines here, we see, okay, we can create and manage our hazards using the hazard analysis and risk assessment document. So we will open up this document. It looks similar like our item definition. We have here a table referencing the author, the reviewers, and the revisions. And if we scroll down, we have here a chapter containing the defined hazards. Currently, we have one possible hazard in our system defined. It's the unintended parking activation. What else can happen? What other hazards are possible? Well, another hazard could be an unintended loss of the brake force. So if you like to add another hazard, it's just return, and you see here there is a new work item added to the document. It's of type hazard, and we can list here unintended loss of brake force. We could describe it in more detail. While parking on slope, there can occur loss of brake force due to low battery. Okay, so let's move this around and just save. You see we have here all attributes of fields which are requested by the standard to define a hazard. So we will have the need to define the operational situation, and we can use here the Polarion work item properties pane to add this information. The operational mode, well, we have defined it's parking on slope, so the mode is stationary, and the operational situation is while parking on slope. By the way, the list elements here can for sure be configured up to your needs. So the consequence, what will happen if we lost our brake force? Vehicle moves down. Okay, let's save. So we have defined our hazard, and the next step is, if you look back into our how-to, is the hazard classification. So how it is done? It's done using the 3 parameters: exposure, controllability, and severity. So let's go back to our hazard analysis and risk assessment document. And there we have our defined hazards. What you can do is, you see, we have different status here. This one is already classified, and our new added hazard is still in status draft. It's not classified. So what you can use Polarion for is to filter this information. So if you have planned a review of your hazards to classify them, you can just filter only hazards which are currently in status draft. So this is very easy. If you're using Polarion, you can switch the view here and say, okay, well, now I like to have a table view, and I'm only interested in type hazard, and additionally, I like to see only hazards which are in status draft. So you see the list is filtered here. I have here only hazards which are not classified so far, and we will start classifying our hazard unintended loss of brake force. So what we will do here is we will add the severity. So looking up into the table, I would say it's we could describe it as S2, because if someone is walking here and the vehicle starts moving, this person can be hurt severe. Description of exposure. Well, the exposure, I will rate it around E1. You will not so often park on a slope. Well, it depends where you are living, if you're living in the mountains or not. So if we are in the mountains, let's go a little bit higher. We say, okay, it's E2, and the controllability, will it be possible to control the movement of the vehicle? Well, it depends whether you are an infant or child or just a woman like me. So I will rate it to C2, and we'll switch here the status from draft to analyzed. And what Polarion will do for you is, if you save here, it will calculate the ASIL determination according the standard for you. It will look for the 3 parameters and calculate the rating or the ASIL level for you. You see, well, for this hazard we would be we need not to do more. We have a rating around QM. Let's go send it back to draft and rate it a bit higher. So we have to follow our hazard analysis, because we'll have a rating higher than QM. So we switch it back to status draft and recalculate it for an S3, and the controllability, well, let's say it's not controllable, and again switch to analyzed, save this one, and you see, okay, well, the ASIL is calculated again. It's ASIL B rating now. So let's check our ISO 2626 how-to. What are the next steps? What we have done so far, we have done the hazard identification, hazard classification, the ASIL determination was done automatically by Polarion. The next step is to define a safety goal for each hazard. So let's go back to our table of our hazards. We have here our unintended loss of brake force, and we will say, okay, we will define or assign a safety goal. What is our safety goal? So the safety goal could be guarantee the specified parking brake function in all environment situations. Okay, what ensures Polarion ensures that the ASIL is inherited from the hazard, and you see here it is inherited and set to ASIL B according to our hazard definition. So the next step downhill is to define the functional safety requirements, and we can go here and say, okay, well, we have defined our safety goal. What functional safety requirements can be or are derived from our safety goal? So again, Polarion takes care that the ASIL classification or ASIL inheritance is done. It's according to the safety goal. Our functional safety requirement inherits the ASIL. So what possible functional requirements can be specified here? So we need to maybe read in battery signal. So we can ensure that we can do maybe a mechanical rotation, so the brake force will not get lost due to a low battery. Okay, so we will define an additional functional requirement, safety requirement for our safety goal, mechanic blocking component. And okay, so what we have done so far, we have defined the ASILs, we have classified, we have defined a safety goal, and we have defined functional safety requirements. What Polarion gives you is you have always the complete traceability information. So if you use here our hazard traceability shortcut, we will see the traceability of our hazards down to the functional safety requirements, and later on down to software safety requirements, down to the test cases which will verify or validate the hazard. So it's very easy to create the so-called safety case to show what has been done to mitigate our hazard. So we have here our unintended parking activation. We have defined two safety, we were here for unintended loss of brake force. We have defined the safety goals, and linked or derived are the two technical safety functional safety requirements. So looking into ISO 26262, how to again. So what is here? The last step in our concept phase is the specification of the technical safety of the functional safety requirements of our functional safety concepts, and then it goes down to the other domains like the product development, like the software development. You can integrate now your hazard analysis with your other areas, like we can say, okay, where is my hazard let's check again our hazard traceability with our report. Unintended loss of brake force. One thing was read in the battery signal, and I can say, okay, I go down and I will define a functional safety, a refining safety requirement, and this is a software requirement. So I need a function to read in and calculate the battery signal. Read in and calculate battery signal from CAN bus. You can integrate this with your whole development, assign these safety requirements maybe to a release like version 1, and if you look in our release planning, everything is integrated. Look into our version 1, we will see, okay, there is requirements planned for our version 1, and there is our safety requirement, our software safety requirement about reading in the battery signal from the CAN bus, and this is handled like all other functional requirements in our project. Okay, so far a short introduction to the Polaren ISO 2626 template. Let's check whether there are questions. Okay, we have two questions here. One is about the ASIL. Is the ASIL for each item or for the whole system? Well, the ASIL is for each function of your system. So you are looking in this sample, our system, or like the norm or the standard mentioned, our item is the electronic parking brake, and this electronic parking brake system provides a couple of functions, and you look at each function, whether this function can or can raise a hazard or can harm your driver or your passengers. So the ASIL is for each function of your item. Another question is about the disassembling of the product. Well, the disassembling for a vehicle is, well, it's not a good sample, but the disassembling means if your vehicle, first you have the development process, then you will start the production of the vehicle, and the vehicle is used by the customers, by your drivers, by your participant. And this is the so-called operation or maintenance period. And the part 7 of the standard focus on this period, the maintenance and the operation period. Well, the disassembling, I guess this is it comes from the EEC 61508, where you have focus on plants or factories, and there you have the need for disassembling. So maybe it makes not so much sense in the point of automotive or vehicles. Okay, the next question is, what is QA? We have it seen here if we look in our ISO 26262 how to, if we have the classification or the determination of the ASIL, there was a rating called QM. QM stands for Quality Management. This means you do not need to add additional actions according to ISO 26262. The ISO 262 only requests additional action or work products or measurements if you have an hazard rated for ASIL A, B, C, or D. Okay, then there's a question about the interfaces to the outside world, like requirements tools like DOORS or test automation tools or Excel. Yes, Polarion has interfaces to the outside world. There are integration for DOORS or other test automation tool with HP Quality Center, and Polarion also provides a very deep integration with the Microsoft Office tools like Excel. There is an Excel round trip. You can import Excel sheets. You can export information from Polarion to Excel sheets, and you can also change the Excel export sheets and re-import it back to Polarion. Well, there's one question about the license costs of this tool. I would suggest you to look on Polarion homepage at polarion.com, and there you will find all the information around the products, because the licensing costs are different between the different tools. If you're maybe here interested in the ALM tool, just select here, and there we will find pricing information also. So then there's another question popping up. It's a very, very good question. What is the difference between FMAI and ASIL? Well, I've tried to figure it out. From my point of view, the ASIL is from a very, very high level perspective. You're looking at your item, looking at the function of your items from the point of your driver. What will happen when something goes wrong? The standard ISO 262 uses FMAI at the system area or at the hardware and software area to prove that your safety concept is able to mitigate the risk. Okay, hope I've answered all your questions. So we have just left one slide. Oh, sorry, with two slides. So what's the main idea behind integrating the hazard analyzing with an ALM solution? It's the idea to integrate all your project artifacts to get it traceable and auditable. What can you do if you say, well, Polarion looks nice, I need more information? Just go to the Polarion homepage at polarion.com. You can download a free trial. You can try Polarion Live. Polarion provides hosted servers where the Polarion's products are installed, and you can try Polarion Live on a Polarion service without any installation on your PC. You can watch videos or short viewlets about the concepts. Looking here in the area of the resources, you'll find a couple of tutorial videos like what are the Polarion documents, how can I create a document, how can I add work items, how can I use the round trip. By the way, there's a very nice integration with Microsoft Word. Okay, so there are popped up two more questions. There are about ASIC decomposition, and well, we didn't cover ASIC decomposition in this session, but maybe we will follow this up in another webinar. The acyl decomposition is a concept how you can reduce the acyl by dividing one functional safety requirement into two or more functional safety requirement with a lower acyl. And yes, currently in the ISO 2626 Polar project, we do not have support for acyl decomposition, but you can do it manually and reduce the acyl level in your functional safety requirements. This is allowed. Okay, so fine. Thank you for your participation, and thank you for your great questions. I wish you a great, great lunch or great evening, and hope to hear or see you again. Bye.